So, exercise number 11, write a program to display all the prime numbers within a given range. This was requested by many of my students. Let's write a program for this. All right, so beginning. So beginning here simply means the beginning of the range, the given range, from which number to which number. So beginning, let's let it be 25. All right, but we have to we have to write a program by to execute all the prime numbers from given range. So the beginning of the range should be given by the user. So let's input this. Since since anything entered by the user is in string, we have to convert it into integer. So this is for the integer, to convert it into the integer. All right, so input enter the BEZINNINZ beginning. All right, let's enter it over here. This space, you'll know it later why I've given this space. Now let's end. All right, int input enter the end. Put it over here. So print. And now let's give space over here, right? And print. This will give us certain space. All right, so let's see. First of all, print following are the prime numbers. All right, let's keep it in the middle. Okay, so here is fine. First of all, let's execute this program. From here, display prime numbers from here, space over here, this space over here gave a particular space over here. See this? 5 and another is 50. Following other prime numbers, and all the prime numbers will be shown downwards. All right. Now let's continue. Let's give a variable. All right, a is equals to 0. You'll later know why I've given this. Now let's see. If I let's give a value. All right. So for num in range, suppose the range is from 9 to 20. All right, suppose the range is from 9 to 20. If I print num, so let's see the value. All right, let's see the value. See, it prints from 9 to 19. It didn't print 20. All right, so the range is the range excludes the end, the given end. Therefore, over here I have to write end plus 1. All right, so since it excludes the end digit, we have to create a new end, that is plus 1. All right, so now for here to there, but if num is greater than 1, so you'll ask me why I've given the num greater than, since the 1 is also not divisible by any numbers, it will print 1 as well. Therefore, we have to exclude the 1. So num should be greater than 1. Then only this loop will be executed. If num is greater than 1, we'll again create a loop. This loop is created to check whether this is prime number or not. So for num, for check, that's right, it's given name check in array and range from 2. So I have to, since we excluded 1, we have to give a new range from 2 to the given number. So that is num, given number. All right. But if the given number has uh, any factors except the one and itself, then we have to break this loop. So let's do this. If uh, if num, see, this is factorial. This number, if not factorial, it gives the remainder actually. Suppose if I let's do this. Suppose if e is equals to 10 factor 3, and print if I print a and run this program, say 1. So when 3 is divided by when 10 is divided by 3, the remainder is 1. Yes or no? If I delete this and I write 9 over here, and I by 3, and if I execute this program, see, you will get 0. Say 0 because 9 is divided by 3. We have to check that. So if num when if num factorial check is equals to 0, then we have to break this loop. All right, we have to break this. Sorry, we have to break this loop. All right, else we have to print the number because it is else because it is the prime number, right? So print. Now you will see why I've written that a, this a, why I've written a. Now see, it is to, now let's write a is equals to is suppose let's write a is equals to a plus 1. All right, and if I write over here a, if I write, and now let's give a function over here. See, a, all right, dot, that's what we have to create. We have to create that num. We have to print that num. So if I do this, now you get an interface. All right, so let's give a beginning. Beginning is 25, end is 50. Other prime numbers. It's easy. Thank you. Make sure to subscribe the channel.